Hi there, pre-algebra students. Today what we're going to be starting is a unit on the real number system, and that unit begins with us talking about squares and square roots. So this builds off of our learning on exponents, and basically what a square is taking any number and raising that to a power of 2. So today, as we go through the lesson, I'm going to be helping you fill in your handout here, and you're going to be using your student handout to help you later on with the homework tonight. So this first section, there's two parts when we're talking about numbers: squares and square roots. So squaring a number means taking whatever the base number is and raising that to a power of 2. So for example, 4 squared, or 4 to the power of 2, would equal 16, because basically what I'm doing is taking 4 and multiplying it by itself a second time. So that would equal 4 times 4. Here's one 4 and here's the second 4. So I know from my basic math facts that 4 times 4 is 16. Now on the other end of the spectrum, when we're talking about negative value numbers, integers, when a negative value is squared, we have to think to ourselves whether or not the negative sign is in parentheses. So when we have that negative sign here in the parentheses, that means take negative 2 and multiply it times itself. And whenever we multiply a negative times a negative, we get a positive. It's inside of this parenthesis. So negative times itself, this would give us 4. When the negative is not inside of the parenthesis, that means take the base number and bring it to whatever power. In this case, we're doing square, so the power of 2, and then we have to keep that negative symbol there. So here it's a negative 4 because it's not in the parenthesis. Here we have negative 3 in parentheses to the power of 2. So what I'm going to do, just like the order of operations, I'm going to solve this negative 3. It's in parentheses, so negative 3 squared is going to be positive 9. But here I have 3 to the power of 2, or 3 squared, and that's going to be a negative. So here it'll be negative 9. Now the next one, I have negative 4 to the second power, or negative 4 squared. That's going to give me 16 because it's inside of the parenthesis. Here the negative symbol is outside of the parenthesis, so 4 to the second power, but that's negative, it's negative 16. So those are squaring the number. Again, anytime I say what's the square of 8, 8 squared would be the same as saying 8 times 8, which is 64. Any base number squared means to take that number and multiply it times itself. Now on the other end of the spectrum, sort of the inverse, is called the square root. So taking the square root is the inverse or opposite of squaring a number. So in this case, what they're going to do is basically give us the product. They're going to give us the answer of the multiplication problem, and they're going to say if you found two numbers that you multiplied together that are the same, which would equal this number. So the square root of 16 is both 4 and negative 4, because 4 to the second power is 16, and if we put negative 4 in parentheses to the second power, that is 16 as well. So the positive square root is known as the principal square root. So, and when we use this square root sign, the solution to our answer is always a positive number. So anytime you see the square root, then the answer to our problem is going to be positive. So 16, in addition to this, because the two numbers are a whole number, 16 is what we call a perfect square. We're going to be looking at some examples of that. So perfect square. So 16 is called a perfect square because its square root is a whole number. So if we think about the number 25, 25 is also an example of a perfect square, because if I took the square root of 25, I would get 5. 5 times 5 is 25. If I think about 36, that is also a perfect square. 6 times 6 is 36. Or 81. 9 times 9 is 81. The square root of 81 would be 9. Those are all examples of perfect squares. So now something that should have been talked about some last year are squares and square roots. So I want you to go ahead. We're going to pause the video here. And I want you to practice your memory of perfect squares and square roots filling out this table below. So squares just means take this base number and multiply that number by itself. That's all we're doing. We're saying square. So in this case, 1 squared is the same as saying 1 times 1. 2 squared is 2 times 2. 3 squared is 3 times 3, and so on all the way up our chart here. So we're going to pause the video, and you are going to go ahead and fill this in, and then we are going to go over the answers together. If you don't know the square of 15 squared, then just write it out. A lot of people don't have beyond 12 memorized. That's normal. So if you need to work it out and show your work. So we'll pause it here, and when we come back, we'll go over the answers. All right, so hopefully you had time to go through these, and now we're going to go over them and see what you remember from previous year's math. So 1 squared is 1. 2 to the second power, or 2 squared, is the same as saying 2 times 2, and that's 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, the same as saying 6 times 6. 7 squared is 49. 8 squared is 64. 9 squared, 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. So these are all going to be very helpful to you as we work through this process, and as we get further into math, knowing these squares. And now we're going to do the inverse. We're going to do the opposite, the square root. So now we need to look at what are our answers to figure out which number goes underneath the square root symbol. So I'm thinking the square root of what gives me 1? Well, in this case, it's 1. So I want you guys to go through. We'll pause the video here, and you're going to go through and you're going to figure out which number goes under the square root symbol to give me this as my answer. So we're going to pause it right here, and we'll come back and check in. So hopefully you guys had time to go through and do your square roots. So we're going to go over this now. Maybe if you couldn't remember them, you found the square answers above, the perfect square answers above, helpful. But these are going to definitely be something you're going to want to refer back to and do your best to memorize. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. And the square root of 225 is 15. Again, that's just saying, if I take this number and I say what two of the same number I multiply by give me this as my answer, that's what I'm looking for essentially. It's exactly the opposite of a square. These are all examples of perfect squares. All right, so now moving on, we are going to take this knowledge and we're going to work and evaluate these squares and square roots. So we're going to zoom in a little bit here, and we're going to look here at number 1. So number 1 has a -7 in parentheses. So remember, if it's in parentheses, that means our answer here is going to be a positive, because a negative times a negative is a positive. So -7 squared is the same as saying -7 times -7. And a negative times a negative is a positive, so our answer here is going to be 49. Now here we have 2/3 squared, so 2/3 squared. So if I take the 2 and I square that number, and I take the 3 and I square that number, it's going to give me a perfect square fraction. So I want you to go ahead and try this one on your own. We'll pause the video and then we'll see how you did. All right, so hopefully you had time to do this one. So 2 squared is 4, and 3 squared is 9, so that gives us a new fraction of 4/9. Now, on number 3, you're going to see that it's a -9, but this number's not in parentheses, so we remember from before that if our answer is not in parentheses, or our base number, -9 is our base. If that's not in parentheses and it's a negative number, then that means our answer is going to be negative. So if I think about this, this is the same as saying 9 times 9, and then I have to put the negative symbol in front. It's not in parentheses, so 9 times 9 is 81, so in this case it's a -81. So now I want you to go ahead and do these 3. These are all finding the square root, so that's just the opposite. Where here I had to multiply the number times itself. Here I need to think to myself, what times what will give me 196 as a product, or 81 hundredths as a product, or 9/16. So what do I have to multiply by itself? So we're going to pause it here, and then we will go over those answers together. All right, so hopefully you had time to go over those and answer them. So you may have to, for a little while, refer back to your squares and square roots chart, just to kind of help you until you get to know these more fluently. So here, since I have a negative before the square root sign, I already know that my answer is going to be negative. And when I think about what times what was the square root of 196, I know that that is 14, because 14 times 14 is 196. Now here I don't have a negative symbol, but I do have a decimal. So this is the same as saying 81 hundredths. And 81 hundredths, I know the number 81, that if I find the square root of 81, that's 9. So this is going to be 9/10. That's the square root is 9/10. This is a fraction, so the square root of the fraction, we just take the square root of each one of the numbers individually. So if I take the square root of 9, I know that's 3. And if I take the square root of 16, I know that's 4. So the square root of 9/16 is the same as saying 3/4 times 3/4. So now I want you to try these ones on your own. Here what we're going to do is we're going to be taking and doing some expressions with this. So here we're going to find the square root of this number, and mathematically we know that if numbers are right next to each other, we're going to be multiplying. So we're going to find the square root and multiply that times 2. Here we're going to add. Here we're going to multiply times -3 and then add 10. Here we're going to be subtracting 2 square roots. We're going to be multiplying and finding the product here, and we're going to be adding here. So I want to pause and have you go ahead and do those, and then we will go over those together. All right, so hopefully you had time to do these. We are going to go through this together now, and we're going to go over how to get each one of the answers. So this, I'm going to leave the 2 alone here, and anytime mathematically when numbers are sitting right next to each other, sometimes they'll put a dot, and sometimes they'll just put the numbers next to each other. So in this case, what we're going to be doing is multiplying after we find the square root. So this, the square root of 64, I know is 8. So this is the same as saying 2 times 8, and 2 times 8 is 16. If I was going to evaluate that expression, I'm going to solve that problem there. Here I'm going to leave the 5 and the plus alone, and then I need to think, well, what is the square root of 121? And I know that the square root, this is a perfect square, is 11. So then I'm going to add 5 plus 11, and I'm going to get 16. So far both answers are 16. This one, I'm going to be following the order of operations. So when I think about this, -3, leave that alone. And then the square root of 225 is 15. And then I'm going to add 10 to that. So when I follow the order of operations, I know that I need to multiply first. So I'm going to multiply -3 times 15. And when I do that, I get a -45. Negative times a positive is a negative. And then I'm going to add that. I'm going to add 10 to that. So basically what this means is that if I have a -45 is in the negative, it's past 0. It's in the negative section of a number line. And if I have a number that I'm adding to it, I'm going right back towards 0. So what I'm going to do here is basically subtract. I'm going to say, what is 45 minus 10? And if I think about that, it's going to be 35. 45 minus 10 is 35. But basically all that's happening is if I had a number line here, and we're -45. If I go back this way 10, let's just say this is 0 here, and then all my positive numbers would be here, 1, 2, so on and so forth. -45, if I'm adding 10 to that, I'm not going to continue going negative. Anytime I'm adding a number to it, it's bringing me back closer to 0. So if I go back 10 from 45, I have 44, 43, 42, 41, 40, 39, 38, 37, 36, 35. That gives me 10. So I'm still in the negative. I'm just 10 closer to 0. So it's not a positive number. It still is a negative because I've not gone back to the 0 point yet. I haven't made it there. All right, moving on to number 10. I'm going to take the square root of each number. So the square root of 144 is 12. And I'm going to subtract the square root of 36, which is 6. So 12 minus 6 is 6. Now in this problem, again, we're going to be multiplying. So I'm going to leave the 15 there. And I just put a little dot there to kind of remind myself that I'm going to be multiplying. So the square root of 16 is 4. So this is the same as saying 15 times 4. And 15 times 4 is 60. That's the product when I multiply them. Now here I have this negative on the outside of my square root. So that means my answer is going to be a negative number. It's not on the inside. So 81, the square root of 81 I know is 9. And then I'm going to add 20. Now this time my answer is going to be positive because if I look at a number line, and here's 0, I have -1, -2, -3, -4, -5, -6, -7, -8. Here's -9. If I add 20 to that, I only have to go 9 to get to 0. And then I still have more to add to get to 20. I still have 11 more to get to 20. So here, what I would do is take 20 and subtract 9 from it. And when I do that, I get 11. You could also draw out a picture of a number line if you wanted and count to get to the -11. But we're starting out at -9, and then to get to 20, we're adding 20 to that. We're going back toward the 0. And here we do go past the 0 because 20 is greater than 9. All right, now what we're going to do is we're going to take that knowledge that we've learned today, and we're going to use it to solve some word problems. So let's read number 13 together, and then I'm going to give you some time to solve that, and then we'll go over it. All right, so here we go. A group of 225 students needs to be arranged in a square formation for a halftime performance show. How many students should be lined up in each row? So there's some key information that they give us here, and what I teach my students is to always underline the important pieces of information here that tell us what we're doing. So I see two important pieces of information here. I see a group of 225 students, and they're saying that they have to be in a square formation. So in order to figure out how many students should be lined up in each row, I need to figure out the square root of 225. So square formation, if I have a big group and there's 225 kids in it, I have to put them into a square, and they're saying if I'm going to put each of the kids, I'm going to line them up and make it in the shape of a square. Each side of the square has to be exactly the same number of students to create a square, otherwise we're creating a rectangle. So if I'm going to do that, I'm going to find the square root of this number, 225, to figure out how many students need to be on each side of my square to make it a perfect square at the halftime show. So if I figure out the square root of 225, we write it like this. The square root of 225, what times what gives me 225. And I remember that 15 is the square root of 225. So in this case, I can't just put 15 because we're talking about something specific. They asked how many students. So in this case, our answer is 15 students. All right, now on number 14, it says, Ivan's room is a square with an area of 144 square feet. What is the perimeter of Ivan's room? So we think about perimeter. Perimeter is what is the length of the sides here. If I added up all the sides, what would it be? So this is going to be a two-step problem here. I'm going to have to think about it. So what I want you to do is I want you to underline the key information here. And we'll pause so you can do that, and then we'll go through and we'll talk about what's the most important information to underline and how to go forth and solve this problem. All right, so you should have had a chance to underline the important information. So there's a couple of key pieces of information here. So Ivan's room is a square, and it has an area of 144 square feet. So I'm going to do my best to draw a square here. We're talking about a square. The area is what's inside. Area is inside. Think about it as the soccer field. If I'm thinking about the soccer field outside, the perimeter is that fence around it, and the area is all the grassy area. So this is 144, and we would say feet squared. So you should have kind of talked about this back in 5th grade and 6th and probably 7th grade when we were talking about area and perimeter. So this wants to know what's the perimeter of Ivan's room. So when we talk about that, when we're figuring out the square, what's the square root of 144, that's going to tell us what's the length of each one of these sides. So 144, the square root of 144 is 12. So that means that each one of these sides is 12. That means this side is 12 feet, and this side is 12 feet, and this side is 12 feet, and this side is 12 feet. So in order to figure out the perimeter, of anything, I have to add each side. So in this case, I have a square. So this is 12 plus 12 plus 12 plus 12. So if I did that 4 times, 12 times 4 is 48 feet. The perimeter of this square, his room, is 48 feet. So that is our lesson for today. What I want you to do is take a couple minutes before the end of class time, and I want you to kind of summarize, write a few sentences that just talk about what did you learn today. So you can use both of these sheets to help you remember what we talked about. This is kind of your ticket out the door. The substitute will check, or I will check, and make sure that you filled this out. If you have any questions, go ahead and ask them at this point. We'll do our best to answer them. If the substitute can't, then we'll write them down and we'll make sure that they get answered. Tonight for homework, you're receiving this sheet. You can use both your handouts that we just did in class as a reference to help you. You're going to want to make sure you put your name and your date, and please put which class you're in. I should remember, but just to be sure. So you have a couple of questions to answer just based sort of off the principles of squares and square roots. And then you're going to be doing some evaluating like we did on this practice sheet. And then down at the bottom, you have a couple of word problems that we will go over. So this is due in its entirety tomorrow at the beginning of class. As a reminder, if this is not completed, you will have to stay after school for a detention tomorrow afternoon to get this completed. So make sure you bring this in with you tomorrow, and we will go over it then. Have a great day. See you then.